Yesterday we talked about moving our graphs left and right. Today we are going to add in the rest of our transformations, stretching, shrinking, and reflecting. You've done the reflecting and you've done just a little bit with stretching and shrinking. We are doing more this year than what you've seen in the past. We will probably spend today and tomorrow on this section. So we'll kind of see how it goes. Same expectations as before. I expect a parent function. How do we show it's the parent function on our graph? Dotted line. And then our final one is our solid. Okay? How many points do you need? At least 3 exact points. And then the correct shape from there. And you can always do more points if needed. Just word of warning, so we've done some Math Excel. We did Math Excel yesterday. Today will be as well. But test or quiz, you have to be able to plot those points on a graph. We will do a handout next week to give you guys a chance to practice that, and probably one tomorrow as well. So we will be practicing that, actually drawing it out correctly. All right, vertical, stretching, and shrinking. Vertical is anything on the outside. Outside changes y and it does what it says. So it's when you multiply a number in front. If your C is bigger than 1, it's a vertical stretch. If C is less than 1, it's a vertical shrink. If it is 1, that would be your normal parent function. So think outside changes y does what it says. When you have those, if it's on the outside changing our y, if you multiply by something bigger than 1, for instance, if I have a graph, and if I multiply all my y's by 3, okay, this is a y value of 0, it stays. But at this point, if I take it times 3, it's going up here. So what it does, it's like if you take a rubber band and you stretch it, it's going to get skinnier, right? So a vertical stretch is making your height get taller, so it gets skinnier when you do that. A shrink, if it's something smaller, so it would be like saying I'm going to take my height times a half, so it's going to make it get shorter and fatter. Okay, so shrink gets shorter and fatter, stretch gets tall and skinny. Horizontal, anything on the inside changes x, and it does the opposite of what we expect. Just like yesterday, we talked about inside x is opposite. Thank you. So if that number is bigger than 1, it's actually a horizontal shrink. If that number is smaller than 1, it's a horizontal stretch. Okay? So inside x always does the opposite. A horizontal shrink and a vertical stretch look very similar. If I take a graph and I horizontally shrink it, I'm squeezing it in, so it's going to get skinnier. If I stretch it, it's getting fatter and wider. All right, so let's practice using this. If I want to graph each of these functions, right, make sure we have our parent function. What is our parent function? X cubed would be our starting function. So what does x cubed look like? The chair. So 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, negative 1 cubed is negative 1, negative 2 cubed is negative 8. That's dashed. Okay. To get our transformation, we need to decide it's on the outside, so that is vertical. It's bigger than 1, so it stretches. So outside is y, it does what it says. So we take each point. Here my y value is 0. Y does what it says. I'm saying take it times 2. 0 times 2 is still 0. Here my y value is 1. 1 times 2 takes it to a y value of 2. Here the y is negative 1. Negative 1 times 2, negative 2. You could do these, but what's going to happen? If I take, here my y value is negative 8 times 2 is going to be negative 16. That's off my graph. So we get something like this. Now, sometimes people have trouble with these. Here's my suggestion. If you are struggling with how we got those points, write out the ordered pairs. Okay, those were the points on my original graph. I told you outside changes y and it does what it says. So that says I'm going to take y times 2. So if I multiply my y's times 2 and my x stays the same, here are my new points. And then are those the points we end up plotting on our graph?
Yep.
Yeah. So write them out if it helps you. If you can visualize them, that's okay too. All right. Any questions on that one? Let's look at the second one. 1/2 x cubed. All right. So inside is x, it does the opposite. That is harder for everybody on these. The ordered pair trick can work. Inside changes x. What is the opposite of multiplying by a half? Dividing by a half. What is, if I'm changing my x, what's negative 1 divided by 1/2? Grab a calculator if you need to. Get those points. Put the negative 1/2 or the 1/2 in parentheses. It's negative 2. All right. Or you could think the opposite of multiplying by a half is multiplying by 2. Multiplied by the reciprocal. So 0 times 2 is still 0. 1 times 2. All right. So if I plot those points, negative 2, negative 1, 0, 0, oops, 2, 1. What happened to my graph? It was a horizontal stretch. Okay. So especially on the inside ones, it's usually harder for people to think about. So those order pairs can be very helpful. Inside changes x, it does the opposite of what it says. So instead of multiplying by a half, we divide it by a half, or multiply by 2. All right, this one, apparently I just missed adding a graph onto this, so we'll have to draw our own. What's my parent function? Absolute value. So the absolute value of 0 is 1, negative 1. If you know what it looks like, that's enough points. If you don't, you can always do more. 2, 2, negative 2, 2, yep, and we get V. Okay, 2 is on the outside. Outside changes y and it does what it says. So what's it going to be? Stretch, which kind? Vertical or horizontal? A vertical stretch. Okay, if you need to, ordered pairs are totally optional. Outside changes y, does what it says. So in these points, I'm just taking my y's times 2. So if you need to write out those points, you can. Or you could just think, here's my y value, times 2 is still here. My y value is 1, times 2 is 2. Y value is 1, times 2 is 2. So that vertical stretch is getting skinny. All right. Any questions there? All right, let's try this one. So my parent function is the cube root. What's that graph look like? Well, not only, that's a square root is what you're thinking of. Cube root though. Cube root of 0 is, oh. Okay. If I did, what's another one we could do the cube root of? 8. So we're not doing square root. Can we do negatives if it's a cube root?
No.
We can for a cube root, we cannot on a
okay.
square root. So you had the right shape, but we just need both halves. Negative 8, negative 2. Okay. So this first one, the cube root of 3x. If you need to write out some points, you don't have to. At least 3 points. Is that 3 going to change my x or my y? Inside changes x, and it does the opposite. So inside x, opposite. What's the opposite of multiplying by 3? Dividing by 3. So 0 divided by 3 is still 0. 1 divided by 3 is 1/3. Negative 1 divided by 3 is negative 1/3. Alright, so if we plot those, 0, 0, 1/3, 1. If you'd done this one, my x was 2. Divided by 3 would be 2/3. Negative 1/3, negative 1. If you did, negative 2/3 be at negative 2. What's happening to our graph? Well, not why. Yeah. We squeezed it in. This was a horizontal shrink. Okay, so when we squeeze it in, it causes it to get taller. This one, what would that be? The two vertical compression or shrink, whichever one you want to call it. I don't care. Yeah, Mrs. Keller called it compression, I think. So here, you can look at your points. Is it going to change the x or the y? It would change the y. So if you need the points, do that. If not, the vertical especially, it might be easier for you than the horizontal. Outside changes y, does what it says. So I'm taking my y values times 2/3. So we have 0, 0, 1, 2/3, negative 1, negative 2/3. If you wanted, here was 2, 8. If I take 8 times 2/3, what do you get? Give me a decimal. Yeah, so just do, what's 16 divided by 3? Okay, oh, sorry, I said 8, but I meant the y. I meant 2 times 2/3. See, you guys were supposed to do what I meant, not what I said. So this vertical shrink or compression just made it get shorter. All right. I want you guys to try 2 of those before I move on. Well, we might do more than 2. I want you to do these 2 and I'll see how we're doing. All right, A, 1/3, you could just say, okay, it's on the outside is Y, does what it says, so it's a vertical shrink or vertical compression. So you're just taking your Y's times 1/3. Okay, you can work through and write out ordered pairs if you need to. If you can just do it on the graph, that's fine, but I better be able to tell that your points are in the right spot. So outside, Y does what it says. So my X is not changing. 0 times 1/3 is still 0. 1 times 1/3 is 1/3. -1, -1/3. So those should be your points so we can see it got shorter and fatter.
On the test, do we have to put the parent function on the graph?
Yes. All right, on B, x squared. So that's our parabola. This is where I saw the mistake. Inside changes x. So it's horizontal, but it does the opposite. So it's a horizontal shrink or compression. Okay, so I'm going to go through and I'm changing my x's, but I'm doing the opposite of what it says. So it said times 4. What do we do to our x's? Divide by 4. So 0, 0 stays. This would be 1/4, 1. -1/4, 1. Okay, if you wanted more points here, if you took 2 times 1/4, you get 1/2, 4. -1/2, 4. Okay, you are getting an extremely skinny parabola here. Hopefully yours is a little more beautiful than mine. My board has a delay in it today. My graphs are not very beautiful. All right, I think we still need a couple more. All right, what's my parent function on this one? Absolute value. So the absolute value is 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. Okay, is this a horizontal or a vertical change? Inside is x, it's horizontal. Does the opposite. So when I see 0.25 or 1/4, I'm thinking shrink, but I know it's the opposite, so it's really going to stretch. If ordered pairs help, do at least 3 of them. This says take my y or my x times 0.25. What's the opposite of multiplying by 0.25? Dividing. 0 divided by anything is still 0. What's 1 divided by 0.25? What's negative 1 divided by 0.25?
Oh, 1.
So, we have 0, 0, 4, 1, negative 4, 1. So that horizontal stretch makes it get wider. If I look at D here, what's my parent function? Square root of 0 is 0. 1, 1. What's another nice one?
May I have your attention, please? At this time, teachers, if you would practice with your students and talk with your students about what you would do in case of an earthquake.
All right, so this 5, outside changes y, and it does what it says. So this would be a vertical stretch. It's saying take your y's times 5. So here my y is 0, times 5 is still 0. Here my y is 1, times 5 is 5. Here my y is 2, times 5 is 10. You can write them out in order of pairs, you get those same points. So, that was a big stretch for our graph. Big stretch, yeah. All right, so for stretching and shrinking, it can sometimes be hard. My suggestion, if you need to, write your order pairs. Inside, X, opposite. Outside, Y, do what it says. Is anyone in here in Dan? So let's talk about reflecting graphs. If there is a negative out in front, that's like saying you make all of the y's negative. I think I put this on the very first slide because I was trying to get it onto one piece of paper. So you would flip or reflect over the x-axis. If all of your y values become negative, it flips it over the x. If you change the sign on your x's, what would that do to our graph? Yeah. So flipping or reflecting, just going to change it over the axis. Out in front makes your y's negative, so it flips it over the x-axis. Inside makes x's negative, so it flips it over the y. So if I ask you to graph this one, what's our parent function? X squared. Parabola. 0 squared is 0. 1, 1. 2, 4. Negative 1, 1. Negative 2, 4. Okay. There is a negative out in front of this whole thing. So that would flip or reflect over what? The x. It's changing the sign on all of my y's. So here my y is 0. It's going to stay here. When my y is 1, it would go to negative 1. This is a y value of 4. It goes to negative. Is that one okay? Let's do this one. So what's your parent function? Square root. So square root of 0 is 0. 1, 1. 4, 2. If you wanted, you could do 9, 3.
Band is dismissed to prepare for the assembly. Band is dismissed to prepare for the assembly.
Pep assembly for girls call. During advisory. Yes, you have to set up. All right. So if my x's are negative, I'm changing the sign on my x's, what will that flip my graph over? Okay. Again, I haven't been doing it, but if you ever wanted to, you can always write out these ordered pairs. If you did that, inside is changing my x. It's just making all of your x's negative. Okay, so you have 0, 0, negative 1, 1, negative 4, 2, negative 9, 3. All right. Do we need more practice with the reflecting? Okay, so what I want to do now is some problems where everything is together. So we can have multiple transformations, yesterday's and today's. I'm going to skip that one. Oh, come on. So, what's my parent function? So 0 cubed is 0. 1 cubed is 1. Negative 1 cubed is negative 1. If you wanted, you could do 2, 8, and negative 2, negative 8.
I was gonna do it this hour when that earthquake came. So,
No problem.
thank you.
You're welcome.
It's all right.
All right. We should be able to describe all of our transformations. So, what would a negative out in front do? Okay, from yesterday, if you subtract 2 on the inside, inside is x, it does the opposite, so it would move it. Okay, order kind of matters. You need to save up and down for last. Okay, but let's just talk through and see if we can do this. So if I take 0, 0, if I flip it, does it go anywhere? Nope, so it's still right there, and then I go right to up 1. Alright, if I take 1, 1, and I flip it, where does it go? So now I'm at 1, negative 1. Then I go right to up 1. So I took this point, flipped it over the x, and then went right and up. Okay, if I took, let's go ahead and do these. If I took 2, 8, if I flip it over the x, it goes to 2, negative 8. And then right to up 1. Okay, if I take negative 1, negative 1, and I flip it, it goes to negative 1, 1, and then right to up 1. One more, negative 2, negative 8. If I flip it, it goes to negative 2, positive 8, right to up 1. Quit talking for 5 minutes. Give me 5 minutes. Questions on that one? Okay. Our last one for today. Here is my function. What does the parent function look like? Square root of x. So the square root of 0 is 0. 1, 1. 4, 2. If you wanted, you could do 9, 3. Okay, what will the 1/2 do? What's the plus 2? And the minus 3? So, if I'm at 0, and I shrink, it doesn't go anywhere, then left 2, down 3. Okay, here my y value is a half. If I shrink, or is 1. When I shrink it, it goes to 1/2. And we go left 2, down 3. Okay, here my y value is 2. When I take it times a half, we get 1, left 2, down 3. If I wanted to hear my y value is 3 times a half would be 1.5. Left 2, down 3. Questions on that one? So, tomorrow we are going to finish this up. I know